In this video, we're going to run the CPLEX software and program in our first linear program. So I'll do this on a Windows machine, but it should be pretty similar on a Macintosh or Linux. So the first thing that we're going to do is we're going to open up the CPLEX Studio IDE. Now, depending on your computer and if you've run it before, this might take a little bit of time. Now, the first time you open it, it's going to ask you, where do you want your workspace to be? Now, this workspace will help with storing sort of residual files and sort of temporary files that get generated. Unless you're picky, you can just go ahead and select the default. Okay. And so what you should then see is that CPLEX will start loading up. Okay, so now that we have CPLEX loaded, we want to create our first project. And so the way we do that is we go ahead and click New, and then OPL Project. And there's probably a few different ways that you could do that. Again, you could click this little button, or you could go through the file. You might even be able to right-click here, and say New OPL Project. Right. So we're just going to call this My First LP. And here you can see where it saves your LPs and sort of your programs by default, or your projects. So here, phone is the name of my user, and then OPL is where it's going to save everything. And you can see here, My First LP. Now, as part of My First LP, we're going to do two things. First, we're going to add a default run configuration. CPLEX lets you run and optimize your LPs either on your local machines or on a server or in the cloud. Now, we're going to select the default run configuration, which will run right on your machine. Additionally, what we're going to do is we're going to have it create a model file. And this is where we're actually going to type in our linear program. Later on, what we'll do is we'll introduce different ways that we can import data into a linear program. But for now, we're just going to solve sort of a very simple linear program that isn't too complicated. So at this point, we'll go ahead and click Finish. And with your project created, you'll now see a few different files that got generated. First, in the main window, you'll see your .mod file. And this is actually where you're going to program in your linear program. In the run configurations, if you open up this tab, you see it says configuration 1. And if you open up that tab, it actually has a shortcut to your first LP. Now, configuration 1, by default, will run your program locally on your machine. Now, certainly you could pick other configurations that run on servers or run elsewhere, maybe in the cloud and whatnot. Okay, so what we're going to do is to program our first linear program, and we're going to use one from class. And so here in this Excel file, or PowerPoint file, I have a simple linear program. And this is, again, one that we did from class. And so what you can do is you can go back through your notes and actually verify that we ended up getting the same answer as before. So what I'm going to do is program up this LP and show you some of the structure that we have to keep track of. Right. So the first thing that we're going to do is we're going to define our variable. And the way that you do that is by typing in dvar, and then you tell it what type of variable it is. Now, in our case, we have real continuous numbers, or floats, and we want them to be positive. Okay, so that corresponds to saying x1, x2, x3 is greater than or equal to 0. At this point, we type in our variable name, and then we end the line with the semicolon. And we can repeat this process 3 times for each of our variables. So I'm going to define x2 and x3 here. All right. At this point, Actually, let's go ahead and comment this. So if you ever want to make a comment, you can just do a slash. Oops. Variables. Actually, I think it's the other way. There you go. Double slash. And that will comment the line out. Okay. So next we can actually type in our program. Okay. Now the first thing that you're going to want to do is you're going to want to tell it whether you want to maximize or minimize a function. Now in our case, we're maximizing 60x1 plus 30x2 plus 20x3. Okay, so hopefully I typed that in right. Now, the one thing you want to be careful about is that between each of the coefficients in the variable, you want to make sure you have the multiplication symbol. So if you were to just type in 60x1, 30x2, 20x3, you would actually get an error. We're going to go ahead and put those guys back. And the other thing that you see is we're getting this x that's indicating we have an error right now. And the reason is because after each line, or at the end of each line, you need a semicolon. So I'll go ahead and put the semicolon there. The next thing we want to do is start filling out our constraints. And just like we write such that, we want to do the same thing here. Now, CPLEX doesn't actually use such that. They actually use subject to. Okay? And you can see it's a keyword because it turns that text blue. All right. The next thing you want to do is you want to indicate that you're going to have multiple constraints. And the way you do that is by typing in a curly brace. Okay? So we're going to have multiple constraints inside of that. And so you want to say this is all part of our subject to constraints. Now it's at this point that we can actually start typing in our constraints. So let's go ahead and type that in. All right, so we have 8x1 plus 6x2 plus x3 is less than 48. In order to indicate less than or equal to, we type it in as follows, so less than and then the equal sign. When we're done with that constraint, we put a semicolon. Now the important thing to note here is that we have all our variables on the left-hand side and then a constant on the right-hand side. And so this is going to be very important. If you were to put x1 on this other side, it would actually not work when you tried to solve it. And we'll break this in a few different ways later on. All right, so now that we have our first constraint, we can type in the next constraint. So we get 4 times x1 plus 2 times x2 plus 1.5 x3. And I think that has to be less than or equal to 20. So let's go ahead and check that. All right. So our next constraint is 2x1, 1.5x2, 0.5 x3. And what I'm going to do is I'm actually going to make this a little bit smaller so I can look at both at the same time. Alrighty, 2 times x1 plus 1.5 times x2 plus 0.5 times x3. Alright, so our last constraint is x2 is less than or equal to 5. And again, you can kind of see that I'm doing something wrong because it's giving me an error right there. So let's go ahead and type in semicolon. Okay, at this point we're done programming in our LP. If we'd like to run it, we can just go ahead, click our configuration, and press the run button. Now, when you click this run button, you might get a bunch of Windows firewall stuff going on. And what I think is happening is that CPLEX is trying to communicate with the CPLEX server to make sure that your license is correct, that you're allowed to use the software. So I've already run this before, so I might not get these firewall pop-ups, but if you do, just say accept or allow. Okay. So when you click play, it's going to ask you if you want to save the file. So what we've done is we've typed in our LP, but we never actually saved it when we are done typing. If you want to automatically save after every time you make edits, go ahead and just say always save. Otherwise, you can press OK, and the code will, at that point, start to solve. Now, I'm not quite sure why, but CPLEX tends to take a little bit of time to run. Actually, so I'm going to run it again. Yeah. There we go. So you can see that took a bit longer than expected. I'm not quite sure why, but it's just something to be aware of. If you notice you click play and it's not really doing anything, that tends to happen. So what you can see here on the bottom is that it actually gives you the solution to X1, X2, and X3 of this optimization program. Additionally, it gives you the objective function. All right, cool. So if you go back to lecture, you should see that this solution matches what we actually solve for using the simplex method. All right. The next thing I want to do is I want to show you what happens if we were to program this a little bit differently. Not that you have to, but this should show you sort of how we could program this differently and it would still work. So as we've programmed it, we have these less than or equal to's. Now, let's say we wanted to put in the slack variables ourselves for some reason. One way we could do that is by just converting all these less than or equal to's into equalities. And so we're going to add in S1, S2, S3, and S4 in order to do that. Now, adding in those variables is going to require us to define them. So we're going to define 4 new variables, and I'm just going to copy and paste to do that a little bit faster. So I'm going to change this to S1, the next guy to S2, the next variable to S3, and then finally S4. At this stage, I can start adding in each of those slack variables, and I can set the inequalities to equalities. Now, the important thing to notice is that CPLEX doesn't actually use a single equal sign in the constraint equations. So what we're going to want to do is actually type in equals equals. Right? So we'll do the same thing over here. We'll add in S2, add in S3, and finally we'll add in S4. Yeah. Now, if we run this program again, we should expect to get the exact same answer, because all we've done is convert our program from having less than or equal to constraints to having equality constraints. Right? So we just put it in standard form. So the LP is functionally the same. All right, so let's see what happens when we press play this time. So we're going to go ahead and save it. And you can see it sort of running right here based on the icon. And at this point, we can see our decision variables are still 2 and 8. Our objective value is still 280. But now we see the values for our slack variables, 24, 0, 0, and 5. And again, if you go back to the simplex method in the lecture, we ended up with this exact solution. All right. Now, I want to teach one more little trick. Sometimes you don't want to write your cost equation out right here. Sometimes you want to change it up a little bit. And so what you could do is you could, in fact, define a variable. And I'll just make it a float because maybe this cost function could be negative. And we're going to call the cost function cost. Okay? And what we can do is instead of typing in the cost equation up here, we could just say we want to maximize the cost. Now the problem is we have to define what the cost is in our equations. Now it would be nice to do something like this, where we say cost is equal to 60x1 plus 30x2 plus 20x3. But you can see right away we get an error. And the reason for that is, again, you can't put your decision variables on the right-hand side. You can only have numbers here. And so the way that we can get around this is by moving all these variables to the other side and setting it equal to 0. So I'm going to set that equal to 0, and I'll make all these subtractions. Alrighty. Oops. And of course we need a double 0. In fact, oops. Actually that might have been my error. So let's try doing this first. Let's see if this actually works or not. All right. So we'll go ahead and save it. You can see it thinking, oh, and in fact it does run. So this is actually a bit surprising to me. Normally the LP files don't work when you try doing that. Okay, so that's actually kind of fun. So this tells us we can actually write our variables in any order that we'd like. So an alternative way to write this equation would have been to put subtraction signs all over the place equals to 0. Okay. Oh, we need double equals. All right. So again, if we do this, we should get the exact same answer, because all we've done is move all the decision variables to one side. And sure enough, we get the exact same answer. Now there's one other little trick that we can use. Some folks will actually define their cost function up in this top part of the code. So maybe we'll call it objective function. And what we can do is, just like we can define variables, we can define expressions. And so we're going to define an expression that's a float, and it's going to be equal to cost with all these guys. Now the only thing that we need to then do is just add our semicolon, and we are good to go. Oh, and it's giving us an error. You see name cost already defined, and that's because I had previously defined it as a variable. So let's go ahead and get rid of this guy. Okay. Now running the code, I'm going to go ahead and save. We see it running down here, so just be a little bit patient. And there we go. We see all our decision variables again. We see our objective value. And down here at the bottom, you can see that our expression for the cost is in fact calculated. So with that, you now should be able to program up a simple linear program in CPLEX.